Hello, good morning, students. I got a little bit
Good
late.
morning, ma'am.
Good
Good
morning, ma'am.
Ma'am,
Good morning, ma'am.
morning. My laptop was not opening. I don't know why. That's why I could not make you join. Anyways, you can see the PPT, yesterday's PPT that I told you. We'll continue with this. Okay. So, okay, before starting, let me tell you one thing. Whatever doubt you will have no in LPP, few of you have uploaded that Saturday's assignment, or then I had not checked also yesterday. So I'll have to see how many of you have finally uploaded. So till that part of the LPP, if you have any doubt, any sum is undone, anything is not understand not being understood by you, you want explanation, anything, you just keep note of all those things, okay, and keep it in your copy, hard copy. When we will rejoin the college, then I will see those, okay. And those who have not understood anything at all because of not being attentive in the class or anything like that, for them I will think afterwards. If I have time after finishing the syllabus, then I'll again take up LPP, okay. So for those who are doing seriously, I'm saying to them that if you have you have some problems in which you had doubt, you need explanation, you did not understand some part, anything, you just note it, okay, keep mark of it in your copy itself and show me when we'll meet, then I'll clear all those things, okay. So now no more LPP. Today we'll finish off LPP. It's been almost 2 months. So we'll finish off close LPP today, and tomorrow onwards we'll start a new fresh chapter. Okay. So in your screen you can see the this was yesterday's discussion. What will happen if the objective function coefficient changes? So with what we found that if the change is a minor one, then there will be no such change in the obviously the feasible region will not change. Also, the optimal corner point may not change also, because the change is a very coefficient change is a very minor one, that it did not have any impact on the optimal corner points. So that's why we saw that when we changed the coefficient of tables from 7 to 8, then we got the same corner optimal point, okay. But in the second case, when we saw that when we are changing the coefficient by a greater degree and by a lower degree, quite greater degree and quite lower degree, there is a difference of 4 points. You can see four coefficients points are being differed in the second example. Then we saw that although the feasible region did not change, because we have not changed the constraints, no, we have not changed the constraints, and this feasible region is drawn based on the constraints straight line, so it has not changed that. But the optimal corner points have changed when we changed the coefficients by quite a greater degree and quite a lesser degree, okay. So it happens. Then what this slide was not discussed, so I'm starting from here. There is a range for each OFC where the current optimal corner point remains optimal. So there will be a range for each of the objective function coefficients, where you will see that the present optimal corner points will actually remain optimal. We have seen this in the first case. If the OFC changes beyond that range, a new corner point becomes optimal. So these are the two highlights of the calculations and representations of those changed calculations in the graph. These two are the highlights. The first highlight say that there is a range for each of the objective function coefficient where the current optimal corner points will remain optimal, they will not change. And if that range, just a second, a lot of people are joining, let me bring them in. Yeah. So, but if that OFC changes beyond that range, that means we have seen that when we changed by 1 point for the table for the table's coefficient, there was no change in the optimal corner point. So that change in the OFC was in that particular range. That did not cause the corner points to change. But when that went off beyond the range, that means when we increased by 4 coefficient points for the table and then we decreased by 4 coefficient points for the tables, then that change went beyond the range. That's why we saw a new corner points becoming the optimal ones. Okay, this in this calculations, in these examples, the calculations have not been shown. If you calculate and plot them in a graph, they will occur like this. Okay, I have checked, it is correct. All right, then the second change in the sensitivity analysis economic interpretation was what? The right hand side changes of the constraints. What we are doing, by the way, we are doing economic interpretation of what? Sensitivity analysis in LPP. Okay, we are doing economic interpretation of sensitivity analysis in LPP. This is what we are doing. Okay. So first, I'll take you back to the previous slides because I need to show you that what are the two sensitivity analysis changes that we are going to bring. The first one is OFC changes, that we have seen what happens when OFC changes. Now we will do the right hand side changes. Right hand side of what? Who will tell me the answer? Right hand side of what? Right hand side of? Now we will
Constraints.
change, yes, we will change the right hand side of the constraints. Now we are changing this painting constraint. This was the first constraint. So far I remember, this was with respect to the painting hours. So what if the painting hours available changed from 1000 to 1300 units? Now we are changing the right hand side from 1000 to 1300. This increase in resources could allow us to increase production and profit because we are increasing the resource. This is a time resource, isn't it? This is a time resource that the company was utilizing in order to paint the tables and the chairs. Now, if we increase this painting hours, if we increase our resource, obviously this will have an impact on the production and profit, and there is high chance that it will allow us to increase the production and obviously the profit. Now, what are the characteristics? Just like the OFC changes, there will be some characteristics here also. What does it say? The constraint line shifts. Now, what will happen? You think about the graphical solution of LPP. When we used to plot the constraints by taking the equals to sign into consideration only, and then we used to take one of the variable as 0, then we plot one point, then we used to take the other variable as 0, again we plot that point, and then we found the straight lines. I hope you remember that. So what if that right hand side is changing, obviously the constraint will shift, isn't it? The constraint will shift now because the right hand side is changing now. That equals to signs will in the number on the right hand side of the equals to sign will change. Thus the constraint will also shift now. The straight line will also shift now, which could obviously change the feasible region. Now the feasible region will change because why? How we identify the feasible region? We identify it by joining the common points, common areas shaded by the straight lines drawn after taking one and the other variable as 0 simultaneously, isn't it? So we plotted straight line, then we had shaded the common region. Now if that straight line is shifting, obviously the feasible region will also shift. That is implied. Then second point says the slope of the constraint line does not change. However, the slope will not change because it will look similar as we are not changing the coefficient, isn't it? We are changing the constant part of the constraint. We are changing the numbers. We are not changing the coefficient. That's why the slope will remain same. It will not change. That means the look of the line will remain same. Now, third point, what does it say? It says the corner point locations can change. Now, the corner points or locations also can change. Since the feasible region is changing, that shaded area will change. That's why the corner points has also got a chance to change, obviously. And the optimal solution also can change. Let's see with the help of a diagram. You'll see here, old optimal corner point where the profit arrived at 4040. Okay, so this we are taking the old one because we are not changing the coefficient of the objective function, but we are changing the right hand side of the constraint, first constraint. So when we when the constraints right hand side was 1000, this red line was the old straight line. Okay, this is the old straight line, and in there this point was, you can follow my arrow on the screen, this point was the optimal point. Here the region was the green part, you see on your screen, the green part was the original feasible region, I mean the old feasible region. Now when we changed the right hand side from 1000 to 1300, we saw a shift. This blue straight line became the blue straight line became the new straight line for the painting constraint. Okay, in that, if this is happening, then the feasible region also is changing, it is becoming larger now. This blue part is also coming into this feasible region. Okay, previously it was only the green part, now it is extending till the blue part as well. So it is becoming like this one, this point, then straight away this point and this point. Then when we will calculate, we will see that the optimal point is also changing. Previously it was there, now there is no corner point here at all. So there won't be any optimal corner point at this point. That's why we will have to check this point, this one, and this one. 4 points are becoming the new optimal feasible region, and out of these 4 corner points, this point, you can see the third arrow, this point is giving you the optimal corner point. That means here the profit is the maximum one. Understood? I hope it is clear, because it's very easy to understand. Once you are changing the constraint, obviously the feasible region will change, because that straight line is changing and the common shaded region is also changing. Thus, the corner points are also changing, and hence the optimal corner point will also change. Sometimes it may not change also. Had it been here, then it would not have changed. Had it been here, it would not have changed. 2 points have changed, no, in the new optimal region. So had it been here, and this can change also. Okay, had it been here, then also it can change. It is not a guarantee that it will not change. But here, when the corner points are changing only, the optimal corner points is no longer there in the new feasible region. That's why there was high chance of the new optimal corner point being occurring, and this has occurred. Okay, so this is the new corner point where you're getting a profit of $4820 you're getting. Okay, now what is the effect on the objective function value? Now there was an effect or not? You see, in the first old optimal corner point, the profit was coming as 4040, right? The profit was coming as 4040. Now the profit is showing how much? It is showing 4820, as the corner points are coming at T equals to 560 and C equals to 180. That's why the profit is also shifting. It is becoming high now. So there is obviously an effect on the objective function value. What is that effect? Numerically, you can see on your screen. The new profit is now how much? It is 4820, and the old profit is 4040. Old profit was 4040. So there is an increase in the profit. How much increase? You will deduct this 4040 from 4820, and you will get $780. From where it is coming? We have increased the resource of painting hours, available painting hours. By how much? We have changed it by 300, isn't it? It was 1000, we had made it 1300. So now how this profit increase is happening? It is happening from 300 additional painting hours. All right. Thus, $2.60 in profit per hour of painting. We have just divided in order to calculate the profit per hour of painting. The profit increase per hour of painting. Each additional hour will increase profit by $2.60. Isn't it? Each additional hour is going to increase your profit by $2.60. But what will happen if you lost this additional hour? If you don't utilize this hour, then each hour lost will decrease profit by 2.60, isn't it? That will be an opportunity cost for you. You are not utilizing the increased painting hours. That's why it will bring a loss, or it will decrease your profit. In a sense, it will decrease your profit by $2.60. Understood? So this was the entire description of economic interpretation of sensitivity analysis of in LPP. I told you yesterday that sensitivity analysis can be there in any field. It can be in finance, it can be in economics, it can be in quantitative techniques. What is quantitative techniques? These quantitative techniques are nothing but management game. Okay, these are called management decision theories games. These are nothing but the games which the manager plays in order to select the best option for their production process, for assigning roles. In everything happens in the production department, basically in the production department, and the managers make optimum utilization of these quantitative techniques in order to take the best decision possible. Understood? Any doubt in this, you please ask. Okay, we still have some time in hand, so you can ask. I'm showing you the slides. I'll upload it right now in your Moodle also, so you will be able to see from there, and you should prepare a note out of it. Okay, no need to show the elaborately all the examples, but try to show the graphs if it comes for 6 marks. Otherwise, you can show till what you can do is, if suppose this question is coming for only 4 marks, what you will do, you write this part. Listen to me very carefully. Okay, you write this part, the first line that you can see on your screen. You write this part, then you will not write these examples, no need to write. You will write characteristics of OFC changes. Okay, you write directly the characteristics, then you will not show all these things, not this one also, this is already there. Then you will show these characteristics. So what will you do if it comes for 4 marks? You will write the definition, this one, this part you will write, then you will write the analysis, what it is done. You will especially focus on the graphical, no need to focus on graphical. Okay, just write economic interpretation of sensitivity analysis, like that you write. Then you write that with the help of a graphical representation of an LPP, the economic interpretation can be shown as follows. Like that you will write. Then you will write this part, OFC changes and RHS changes. Then directly you will write the characteristics of OFC changes, and you will write the characteristics of RHS changes. Okay, this much only you will write. However, if it comes for 6 marks, sometimes 12 marks, if you're unlucky, it may come for 12 marks also. So in case it is coming for 12 marks, then you will write the entire thing from this PPT. Understood? Any doubt, please ask. Please ask if you have any doubt. In the meanwhile, I'll take the attendance, and after the class, I'll upload this in the Moodle. Any doubt you can ask. Okay, if you're from tomorrow, yesterday's class and today's class, if you're facing any doubt, any difficulty in understanding, you can ask now. So you will unmute and respond to your names, all right? Abhijit? Abhishna?
Present, ma'am.
Anurag?
Yes, ma'am.
Aryan?
Yes, ma'am.
Ashish,
Yes, ma'am.
Ashmita, Vibesna, Debrupa, Harshita,
Present, ma'am.
Ishika Chaudhary, Ishika Agarwal, Kajal,
Present, ma'am.
Kasak,
Present, ma'am.
Khushi,
Present, ma'am.
Prison, Mahima, Mamta,
Yes, ma'am.
Muskan Prasad,
Yes, ma'am.
Muskan Gupta,
Yes, ma'am.
Namrata,
Yes, ma'am.
Nidhi,
Present, ma'am.
Nitesh, Parnadeep, Pavan, Rashil, Pratiksha Chhetri, Pratiksha
Yes,
Giri,
ma'am.
Present, ma'am.
Priyanka,
Present, ma'am.
Pooja,
Present, ma'am.
Rahul, Rajat, Ramkrishna, Rohit Bansal, Rohit Pandey, Sagar,
Yes, ma'am.
Salina,
Present, ma'am.
Shalini,
Present, ma'am.
Shruti, Siddhant, Saurav,
Present, ma'am.
Subhit,
Yes, ma'am.
Supriya, Suraj, Swayam, Tanya, Vinit. Okay, then I think you don't have any doubt. So we will close LPP today. Okay, no more LPP. Any doubt in any part of the problems we had discussed till date, you please keep a note of it, and we will discuss it when we rejoin the colleges, okay? Or else we after the syllabus also we can discuss. So from tomorrow we are starting a new chapter. The new chapter is called transportation and assignment problem. Okay, transportation and assignment problem. This is a very interesting chapter. You'll have fun in doing the sums. This won't be like LPP, not hectic like LPP. Okay, so all right then. See you at 9:20 a.m. again. You can leave the meeting and join your next class. Bye bye.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.